Well, hello, Earth Space class. This is a video lecture, a short video lecture on comets, asteroids, and meteoroids, as I will have already spoken of in lecture on Tuesday. Just going to start with an image that should be familiar to you. We talked about proofs of or evidences of the solar wind, and in doing so, we talked about comets and what the solar wind does to the tail. If you remember, the tail of the comet is created because of the blasts of energy from the solar, we call the solar wind. So the sun would be over in this part of the image, and energy coming from it would hit that comet and blow a tail out directly away from the sun. That's what creates the tail of the comet, not the motion of the comet. And of course, the comet, when it no longer is very close to the sun, it will lose its tail and kind of wander back out into space in its normal path. If you look at that tail, there's kind of two parts. There's this purplish part and this blue part, and those are actually made of different things. The blue part is the gas tail, and the dust tail is the purplish part. A few years back, NASA sent a probe up to see what actually is a snowball. Is it a dirty ice ball, or is it an ice-covered dirt ball? And they basically shot the probe into the comet and looked at the ejecta that came out of it, and they, from that, were able to determine that in fact a comet is a dirty ice ball. It's a big hunk of ice with dirt covering on it that's floating around up there, if you will. Most comets are found, well, we talk about long period comets and short period comets, and so if you look at the difference between the two, it comes from their origins. So in this picture, this is the solar system. These are the four outer planets, the sun, and then the inner planets be real close there. Well, this would be the outer planets here. This one actually still has Pluto right here in it, so that's awesome. So Pluto and Neptune right here actually are part of or orbit, at least some of the time, within a feature called the Kuiper Belt. Now, Kuiper and Oort were a couple of Dutch astronomers. That's where the name comes from. But there are comets out in this portion of our solar system that are called short-period comets. And short-period comets take less than 200 years to make a lap around the sun before they come back. Well, if you take this whole Kuiper Belt here and you shrink it down to this image right here, this little white circle right here would be the Kuiper Belt. This Oort cloud here, which is way out from it, would contain what are called long-period comets, more than 200 years to make a lap around the sun. But they are still orbiting the sun, but they're a lot farther out. So we tend to find them distributed in either the Kuiper Belt or the Oort cloud. Now, there can be some in between, don't get me wrong, but predominantly we find them either way out here or way in here. And those are comets. We all always think of Halley's Comet when we talk about comets, and of course I'm hoping this will let me do it. I'm going to actually look at Wikipedia here, and this is really good images on Wikipedia. Here's a picture of Halley's Comet. It is a short period comet. It takes 75 years to make a lap. I think it was here last in 1986. I don't even remember looking at it. It wasn't a big deal. Hale-Bopp was a comet that was a bigger deal, but yeah, it's supposed to come back in, what would it be, 2061? Dang, I'll be old and gray then if I'm still alive, but you folks will probably enjoy it. So if you look at it, here's what Halley's path looks like. These are the 1, 2, 3, 4 outer planets, Jupiter, Saturn, Uranus, and Neptune. And so that's where Halley is moving right now. And there actually is a close-up image of Halley's Comet. Here would be the tail, and this is what's at the core of the matter. So it's kind of nice to have that image of what it actually looks like. There is actually evidence that comets have been an issue. You say, well, wouldn't they all burn up as they enter the atmosphere? Well, yeah, maybe, unless they're large enough. There's an area in Russia called Tunguska, it's actually in Siberia, and in, I believe it was 1908, it's believed a comet, well, one theory is that a comet entered the atmosphere at kind of a sharp angle, and it didn't actually, they believe, strike Earth's surface, but it exploded about 3 miles up above the surface, and probably 3 different explosions, and it did this to the trees in the area. And if you go there now, you'll still see evidences of that explosion. This is a more recent image of it from 1908. And the cool thing, they could tell there's 3 explosions because if the trees were directly underneath the explosion, they were still standing but stripped of their limbs. But then they would be blown down radially out from that central explosion spot. And yeah, you know, even a comet, we think of them as small, innocuous, you know, not as big a deal as its close personal friend, an asteroid. But comets maybe have visited us before and have been a problem. So that's Tunguska. Well, let's talk about asteroids just a little bit. Now, whenever I talk about asteroids, there's a couple of images that should come to mind, and I want you to just think about. Well, before I get to those images, I want to show you go back to an image of our solar system. So here's our solar system, and here's the asteroid belt, as you may remember, between Mars and Jupiter. And some theorize that there's enough material there, if it all coalesced, to give us a 9th or 10th planet if Pluto does get reinstated. Ceres is a close associate of the asteroid belt. And then, of course, here's Kuiper belt objects. But that's the asteroid belt. And so what I want you to do right now is to pause this video, and there are 2 clips, the first 2 clips that are actually from the movie, the 1998 movie Armageddon, starring Bruce Willis and a bunch of other guys. And I want you to look at the 2 clips. And one I want you to go ahead to like 2 minutes, 20 seconds, it says on there, and just view a couple of seconds. The first clip is of Hollywood's impression of what an asteroid would be like, and it's just a few clips from the movie, and probably quite unrealistic. And then the second clip is of what it might look like if a significantly large enough piece of an asteroid hit Earth's surface, and this one actually hits Paris. And there, I think they're maybe just a little bit closer to reality. But in reality, then, after you've looked at those video clips, I want you to come back to this video, and I'll show you a picture of what asteroids really look like. Okay, pause. Okay, so hopefully you're back now, and after watching Bruce Willis save the Earth. By the way, NASA did just launch a space probe to, I think it was actually this asteroid, to see if they could alter its path. One of the proposals is an explosion, although I don't think they would drill deep into it like Bruce Willis did, but they are talking about using explosive devices to divert or change the path of an asteroid so that it wouldn't impact Earth. And you say, well, you know, is that really a big deal? Well, an Australian astronomer put this together. You'll notice here, about 2,000 objects massive enough to cause global catastrophe are known to cross Earth's orbit. Okay, we're talking about an Armageddon-like scenario there. In this case, maybe a little smaller. This would wipe out 25% of humanity. Now, the deal is 2,000 objects a kilometer across and bigger are known to cross Earth's orbit. The question is, will Earth be at that spot in its orbit when they cross it? You know, Earth's got a huge orbit. We're 93 million miles from the sun, big, long path. But there are 2,000 objects. And because of Earth's gravitational pull, we are pulling those objects towards us. Will the sun with greater gravitational pull win that battle? We'll see. But you can see some of the other types of things, the size of them and how many of them actually hit Earth's surface. You know, it's something NASA's willing to spend some money on, which is, I think, kind of interesting. So if we go back to this picture, actual picture of an asteroid, there's one look at an asteroid. Here's another image. You'll see that, in fact, they have been hit. Most of them have been hit by other space debris, if you will, that have created craters in them. And here's another picture, very cratered surface. Not at all so irregular as the Armageddon video clip shows, but still, it's kind of interesting. These have hit Earth. We can see places like here in Argentina. Here's a picture of probably some meteorites or some asteroids. And really, folks, the difference between a meteor, and an asteroid, it's just size. It's kind of subjective. The one grades into the other. Asteroids are largely taken as larger in size, and meteoroids are taken as smaller in size. This one came into Earth's orbit at a low angle, and boom, hits there, a piece hits there, a piece hits there, kind of skipped over the surface, but it left scars on the Earth that are still visible there. And so, yeah, asteroids, I'm sorry, do have the chance of hitting Earth, and it would be a very bad deal if they did. If we go back to Google Earth, I think I've showed you the Barringer meteorite. Oops, sorry, folks. The Barringer meteorite crater in Arizona by Winslow. So if we zoom out to there, this one was about the size of a, what did they say, 90 meters across? Or, yeah, not a football field. And just to give you an idea for how big this crater is, and it's actually privately owned, which is kind of interesting. We'll just kind of measure across it. And you see it's 3/4 of a mile across. That was a big boom. So when that actually hit, it leaves, it might completely vaporize the meteorite when it hits. If they're big enough, they can actually penetrate Earth's crust and sometimes be incorporated into Earth's mantle. There can be remnants here. There are actually minerals. I think I mentioned this too. The minerals that are called impactite that are left here in the bottom of the meteorite crater, so that we can distinguish a meteorite crater from a volcano. I'm sorry. And so, yeah, that's a place you might want to put on your visit list. I'll just back out so you can see where it actually is. There we go. So here's Arizona, so you can see it right there. Here's Four Corners region. Yeah, so that's one you can go visit. The last thing we're going to talk about is meteoroids. They're broken up into meteors and meteorites. Meteors burn up in Earth's atmosphere. That's what we call shooting stars. Most of them are about the size of a pencil eraser that burn up in Earth's atmosphere about 50 miles up. It's kind of underwhelming. Don't worry, we will get to structures that do, blow up in a blaze of glory out there farther, hopefully a lot farther. But meteors, shooting stars, are not a big deal. This time of year, as Earth passes through the Geminid and Leonid debris fields, if you will, on our path around the sun, this is a good time to see shooting stars, depending on the year. So there's a bunch of space debris out here that are in those constellations, the constellation Gemini, the constellation Leo, and when Earth passes through them, so that from Earth we look out and we see those constellations, that's where in our orbit we will encounter that debris and have lots of shooting stars. And so those are meteors. Meteorites are the more concerning ones. And those are actually big enough to hit Earth's surface. One young gentleman, Garrett Blanc, back in 2009, was walking home from school, or to school, and as it says here, ball of light, hot, burning sensation on his hand, and then boom, it hits the ground, and it left a 30-centimeter crater, if I remember right, here in the ground. And he was in Germany, and there's a little scar in his hand right there, and there's the piece, what's left of it, that hit his hand. It's kind of interesting. Think about it. This young man was just walking to school, probably dangling his arms, swinging at the side, and this little piece of space debris probably was bigger, but it had just enough energy, enough mass to get through Earth's solar system and hit his hand while he's moving and then hit the ground. I ask you, was that young man lucky or unlucky on that day? I would argue it's kind of lucky because, man, he's got a great story. Didn't hurt him real bad. And he's fortunate because if that had hit him up here, it had gone right through him like a bullet and would have killed him. So, these things do actually hit Earth's surface. And when they do, they're actually valuable. Some people will pay you a lot of money. And if you think about it, a good place to look for a meteorite is on a glacier because they stand out. And there was a guy a few years back that owned a gun manufacturing, high-end gun manufacturing facility. There he is. And he bought this meteorite for $250,000. And he knew that they had variable structure, but this one in particular was an iron meteorite. And what he then did was, well, he created something very interesting. He took that meteorite and made those two pistols out of it. They are actually functional shooting model 1911 pistols, worth a lot of money. Everything in those pistols is made out of the meteorite except for the barrel and these two springs. All this is meteorite. Just the work that they had to do to find the right parts of the meteorite to do that was phenomenal. But you can see there's a pattern to this. That's what helps identify a meteorite. And so if we look at that, it's called actually a Widman-Staton pattern. And this is another thing that helps confirm that, in fact, you are looking at a meteorite, not just a really dark piece of rock, or around here, a dark piece of hematite or magnetite. Okay. So what I want to do right now, though, is to have you pause again and go to the third clip, which is an ABC News clip that talks about, well, a meteorite that actually entered Earth's atmosphere and left kind of a traumatic tail. There's actually a picture of it, and you can see what one looks like. I think this was back in 2014. I might have the date a little bit off. Let's see, just so you can see what the first portion of it looks like. So 2013. So this is the clip. It's about 4 minutes long. I want you to read that, or to view that, and then I'll come back and we'll finish up what we're talking about. So I'll just pause right here and let you go look at that. Okay. So hopefully you've had a chance to view that now, and that's basically as far as I wanted to get to in this video lecture. Comets, asteroids, meteors, meteorites, the fact, the fiction, the fun, the actual risk that they do produce, concerns over them hitting Earth. They are real. It could happen. It has happened. What would happen if they did? Yeah, it's something people think about. So with that, I'm going to pause and have a good day, and I'll see you on Tuesday.